A repo named Private CISA was reportedly public on GitHub, which is a pretty painful reminder that naming something private is not access control. This week, we've got leaked AWS keys, internal deployment docs, Terraform, Kubernetes manifests, Argo CD files, AI root cause analysis, agents clicking through legacy apps, Claude code showing up in CI/CD, and another Kubernetes security reminder hiding in a boring default. The theme is pretty simple. Automation is getting more powerful, but we are still leaking secrets, missing defaults, and writing postmortem action items that quietly go to die. I'm Brian Teller from Teller's Tech, and this is Ship It Weekly. Welcome back to Ship It Weekly, the show where we look at the DevOps, SRE, cloud, platform, and security stories that actually matter when you are the person who eventually has to keep the thing running. This week, we're starting with the CISA contractor GitHub leak. Then we'll get into AWS DevOps agent and automated root cause analysis, Microsoft Copilot Studio computer using agents, Atlassian adding Claude code to Bitbucket pipelines, and CVE 2026-46333 with the Kubernetes Seccomp angle. Then, in the lightning round, we'll hit GitHub expanding OIDC support for Dependabot and code scanning, Java pods getting killed even when heap looks fine, and why LLM-generated SQL can be wrong in ways that still run. And for the human closer, we'll talk about why postmortem action items die. So let's get into it. First up, the big one. A contractor for CISA reportedly had a public GitHub repository named private-CISA. Again, private-CISA. That is like naming an S3 bucket definitely not customer data and hoping AWS respects the vibe. GitGuardian says it found the public repo on May 14th, containing around 844 megabytes of exposed data. Reporting included plain text passwords, AWS tokens, Entra ID SAML certificates, and internal material tied to CISA systems. And this is the part that matters for us. This was not just one forgotten .env file. The reporting describes CI/CD logs, Kubernetes manifests, Argo CD files, Terraform code, GitHub Actions workflows, deployment details, and internal docs. This is not only a secret leak. This is a context leakage. Credentials are bad. AWS tokens are bad. Plain text passwords are bad. But when you also leak deployment docs, infrastructure code, manifests, CI/CD logs, and internal workflows, you are giving someone more than a key. You are giving them the floor plan. Now, we should be careful. From the outside, we do not know the full operational impact. Public reporting says CISA was notified and the repo was taken down. But the lesson is already clear. Secret scanning matters, but it is not enough. The repo should not have been public. The archive should not have been there. The credentials should not have been valid. And once operational context leaks, the response cannot just be rotate the key and move on. You need to ask what the leaked context teaches an attacker. Most teams hear a story like this and think, wow, how does this happen? And then somewhere in their own org, there is a repo called old prod migration backup final, last touched by a contractor in 2022, containing a zip file nobody wants to open because it feels cursed. Most of us have some version of this risk. Old repos, personal forks, contractor projects, build logs, Terraform state, kube configs, migration scripts, weird backup folders. So the takeaway is not just don't commit secrets. That is true, but it is table stakes. The better takeaway is to inventory the weird stuff. Look for old repos, archived repos, contractor-owned repos, personal forks, internal examples, demo projects, and places where somebody may have dumped operational context while trying to move fast. And when a leak happens, treat the context as compromised too. Because sometimes the key is the headline, but the deployment map is the real prize. Next up, AWS published a post on using AWS DevOps Agent to automate root cause analysis across Datadog and Elasticsearch with CloudTrail and EKS involved too. This one sits right at the intersection of useful and slightly unsettling. The AWS example starts with a Datadog alert. AWS DevOps Agent gets access to EKS so it can describe Kubernetes objects, pull pod logs, and look at cluster events. It also correlates Elasticsearch logs, Datadog metrics, and CloudTrail deployment events to figure out what changed. And honestly, that sounds a lot like incident response. You start with one symptom. Then you try to rebuild the timeline. What changed? What deployed? Which pod restarted? What metric moved first? Did someone push a config change? Did a dependency decide today was a great day to build character? Half of incident response is not fix the thing. Half of it is reconstructing the story fast enough that you fix the right thing. So if an agent can gather context and build a decent first pass timeline, that is useful. Logs over here, metrics over there, CloudTrail in another tab, Kubernetes events in a terminal, Datadog on one monitor and Slack on another. And someone asking an update every 90 seconds, which is understandable and still emotionally damaging. But automated RCA can become very convincing very quickly. A tool that says probable root cause with a clean summary can easily become the thing everybody believes, especially when the incident channel is noisy and everybody is tired. So I like the direction, but I would treat AI RCA like a fast incident scribe or junior investigator. Great at pulling threads. Useful for assembling context, helpful for reducing time to understanding, but not the final authority on causality. Humans still need to ask, is this correlation or cause? Did this happen before or after customer impact? What else changed? What evidence would prove this wrong? Because if the incident review action item is that AI said it was Elasticsearch, so we restarted Elasticsearch, that is not RCA. That is vibes with a dashboard. Before we get to the next story, a quick note from this week's sponsor, GuardSquare. If you are building mobile apps, good enough security is usually a problem waiting to happen. GuardSquare focuses on actually protecting your code, in addition to scanning it. That means code hardening, runtime protection, testing, and visibility into what's happening once your app is out in the wild. So if you are responsible for shipping and securing mobile apps, Android or iOS, definitely worth taking a look at guardsquare.com. All right, back to the show. Third story. Microsoft says computer using agents in Copilot Studio are now generally available. This one is interesting because it changes the automation boundary. A lot of automation assumes there is an API. You call an endpoint. You get a response. You wire it into a workflow. Everyone pretends the internal CRM is not held together by 3 workflows, a CSV export, and one person named Linda. Computer using agents are different. Microsoft describes these agents as interacting with graphical user interfaces, websites, desktop apps, screens, buttons, forms. So instead of saying there is no API, so we cannot automate this, the pitch becomes the agent can use the UI like a human. And look, I get why this is appealing. Every company has legacy systems. Every company has some vendor portal that looks like it was designed during the emotional low point of enterprise software. Every company has workflows where someone copies data from one screen into another and calls it a process. If an agent can take some of that away, great. Nobody needs a fulfilling career in manually clicking invoice screens. But this is also where the risk gets weird. API automation usually gives you structure, scopes, endpoints, logs, schemas. UI automation is messier. The agent is looking at screens, reading labels, clicking buttons, entering text, and deciding what to do next, which means your automation path may now include a model looking at a web page and deciding which button seems right. That sounds funny until the button says submit payment, delete record, approve request, or yes, I understand this is permanent. So the governance questions matter. What apps can the agent access? What account does it use? Can it reach production admin screens? Are actions auditable? Can it pause before destructive steps? What happens if the UI changes slightly? And who owns the outcome when it clicks the wrong thing? Computer using agents may become useful because plenty of enterprise systems will never get good APIs. But when the agent operates through a UI, treat that UI like an automation interface. Use restricted accounts. Use test environments. Use approval gates. Log actions. Limit destructive workflows. And be very suspicious of anything involving bulk update. A computer using agent is not just a better macro. It is automation with eyeballs. And like most things with eyeballs in enterprise software, it probably needs supervision. Fourth story. Atlassian says agentic pipelines now support Claude Code as a provider in Bitbucket pipelines. This sounds like a feature announcement until you think about where it lives. It lives in CI/CD. Atlassian's examples include README updates, security report triage, feature flag cleanup, PR descriptions, and other repetitive engineering chores. And this keeps coming back to a point I've made before. Developer tooling is production now. CI/CD is not just the stuff around production. It is the path code takes to become production. So when you put agents inside pipeline workflows, you are not just making developers faster. You are changing the delivery path. And yes, some of these tasks are genuinely annoying. Security report triage, feature flag cleanup, PR descriptions, documentation updates, please take them. Nobody is sitting around hoping for more stale flags and slightly wrong README files. But once an AI agent is part of a pipeline, the boring questions matter. What repository context does it get? What logs does it see? What secrets are visible to that step? Can it modify files? Can it open PRs? Can it change tests? Can it generate security triage notes that humans treat as authoritative? Can it make a flaky test look fixed by weakening the assertion? That last one is not me being dramatic. If the task is fix the failing pipeline, a bad agentic workflow might make the pipeline pass without making the system better. And yes, humans do this too. We just call it temporary and let it survive 3 reorgs. Atlassian also points users to guidance around third-party agent providers and data handling. That matters because if you bring Claude Code into a pipeline, you need to understand what code, prompts, logs, and generated context may leave your environment. That does not mean do not use it. It means do not discover your data flow by reading the invoice. Treat agentic pipeline steps like any other privileged CI step. Start with low-risk tasks. Avoid secrets. Avoid production deploy authority. Make outputs reviewable. Require human approval when the agent changes code. And document what data goes to the provider. The agent does not need to be terrifying, but it also should not be a surprise guest in your delivery path. Fifth story. Let's talk about CVE 2026-46333 and Kubernetes Seccomp defaults. This one is more technical, but it's a good grounding story after all of the AI agent stuff. Because sometimes the most important security decision is not a new tool or a new model. Sometimes it is whether your pods are running with the syscall profile that you thought they were running with. NVD tracks CVE 2026-46333 as a Linux kernel issue in the ptrace path. Qualys describes it as a local privilege escalation and credential disclosure issue. The Kubernetes angle is that unset or unconfined seccomp profiles can leave pods exposed to the tested path, while runtime default block the tested PID FD get FD path. PSS restricted added more protection as well. The operator version is simple. Your Kubernetes security defaults matter, and they matter most when nobody is thinking about them. Seccomp is easy to mentally file under container security stuff we should revisit someday, which is engineering speak for future incident seasoning. Kubernetes docs say that if seccomp default is enabled, pods use the runtime default seccomp profile when no other profile is specified. Otherwise, the default is unconfined. That difference matters because unset does not always mean safe. Sometimes unset means congratulations. You are raw dogging syscalls in production. Probably do not put that in your architecture diagram. So the takeaway is straightforward. Check whether runtime defaults is actually being applied in your clusters. Review your pod security standards posture. Know where unconfined seccomp is allowed. Know where privileged pods exist. Know which namespaces have exceptions. And if you use managed Kubernetes, do not assume the provider magically made your pod security posture sane because the control plane has a nice logo. Containers share the host kernel. That is the deal. So when there is a local kernel bug and your workload security posture allows the relevant path, the cluster configuration suddenly matters a lot. The boring defaults are not boring. They are latent decisions. And every once in a while, a CVE shows up and asks what you decided. Now let's do a quick lightning round. First, GitHub expanded OIDC support for Dependabot and code scanning. GitHub says that Dependabot and code scanning now support OpenID Connect authentication for organization-level private registries for Cloudsmith and Google Artifact Registry. The short version is fewer long-lived registry credentials sitting around as secrets. And that is good. OIDC-based access is not magic, but short-lived identity-based auth is usually healthier than here's a token, please don't leak it, best of luck to everyone involved. Second, Java pods getting killed in Kubernetes even when the heap looks fine. Classic operator trap. Someone sets XMX, looks at heap, and thinks we're fine. Then Kubernetes kills the pod anyway. And everyone stares at the graphs like the cluster betrayed them personally. But JVM heap is not the whole memory footprint. Metaspace, direct buffers, thread stacks, native memory, JIT, GC overhead, and off-heap usage still count towards the container memory limit. Kubernetes does not care that your heap looked reasonable. It cares that the process crossed the limit. So if your Java pods are getting killed, do not only look at XMX. Look at total container memory and leave headroom, because production loves punishing tight memory math. Third, LLM-generated SQL can be wrong in ways that still run. A broken query that fails loudly is annoying, but at least you know it failed. A query that returns plausible nonsense is worse. The dashboard loads. The numbers look reasonable. Someone puts it in a slide deck. And now your business metric is powered by a hallucinated join and a missing filter. So text to SQL needs guardrails, read-only roles, query limits, schema-aware validation, known templates where possible, human review for anything important. The danger is not always that AI writes broken SQL. Sometimes it writes SQL that is wrong quietly, and quiet wrongness is how bad decisions get confidence. The human closer this week is about postmortem action items. Because if there is one place that engineering organizations consistently lie to themselves, it is the bottom of a postmortem document. Not maliciously, just optimistically. The incident happens. People jump in. The team writes a timeline. There is a good discussion. Nobody blames anyone. Everybody agrees on what went wrong. Then the action items show up. Improve monitoring. Review runbooks. Add better alerting. Investigate retry behavior. Clean up ownership. These are not action items. These are wishes wearing a Jira costume. Incident.io had a good piece on why postmortem action items die. The reasons are painfully familiar. No named owner, wrong tracking place, vague wording, and no follow-up cadence. That's basically the whole game. A postmortem action item without an owner is not an action item. It's a group hallucination. An action item that lives in a doc that nobody opens again is documentation tax. And an action item that says improve monitoring is not an action item. It is a mood. A real action item sounds more like Maria adds a replication lag alert for the payment database by Friday. Or Kevin removes production deploy access from the old CI token before the next release. Named owner. Specific verbiage. Clear outcome. Real tracking location. Due date. That does not make the work easy, but it makes it real. This connects back to every story this week. The CISA leak is not fixed by saying review GitHub practices. AI RCA is not useful if the follow-up is improve incident response. Computer using agents are not safe because someone wrote ensure governance. Kubernetes Seccomp is not handled because someone says harden workloads. This is the staff and principal engineering part of the job that does not always look exciting on a roadmap. Turning vague risk into specific work, turning incidents into system changes. That is where reliability actually improves. Because production does not care how good the postmortem sounded. Production cares whether anything changed. Okay, that's it for this week of Ship It Weekly. We covered the CISA contractor GitHub leak, AWS DevOps agent, and automated root cause analysis, Microsoft Copilot Studio computer using agents, Atlassian agentic pipelines with Claude Code, CVE 2026-46333, and Kubernetes Seccomp defaults, plus a lightning round on GitHub OIDC support, Java pods getting killed, and LLM-generated SQL. If this episode was useful, follow or subscribe wherever you are listening or watching. If you're on YouTube, hit subscribe. If you're in a podcast app, follow the show there. And if you know somebody on a DevOps, SRE, platform, security, or engineering leadership team who is dealing with secrets, agents, Kubernetes defaults, or postmortem follow-up, send this one to them. It helps the show grow, and honestly, it helps me keep making this kind of content for people who actually live with these systems. You can find the weekly brief at oncallbrief.com and more episodes and show notes on shipitweekly.fm. I'm Brian from Tellers Tech, and thanks for listening. And remember, if your repo is named private-CISA, your agent can click buttons, your pipeline can call Claude, and your postmortem action item says improve monitoring, maybe take a breath. Then go find the owner, the token, the default, and the ticket. Because production does not run on good intentions. It runs on the stuff that someone actually fixed.